teached anywhere. This is completely theoretical class to understand administration. Splunk administration. Splunk administration is completely involved with the 9 components: forwarders, indexer, searcher, deployment server, cluster master, license manager, deployer, and DMC, distributed monitor console. Okay. So as I said, actually what is our role? Splunk is to monitor our data, monitor the data. For example, I want to monitor his data. I want to get his data to my Splunk server. How I will get it? I need one agent. I will install the Splunk software. Okay. With that Splunk software, I will collect the data and will send the data. You got my point. On that agent, we call it as a forwarder. Okay. On that case, universal forwarder and heavy forwarders also there. Okay. Depends upon the requirement. We will use the universal forwarder and heavy forwarder. Okay. If you want to do some customizations, if you want to do parsings, if you want to do routing, if you want to do masking, at the time we'll use a heavy forwarder. You don't want this requirement. You need to collect the data and send the data, universal forwarder. Got my point? Now, how universal forwarders are collecting the data based on the inputs? How it is sending the data to indexer based on the outputs? Is it possible directly write a inputs and outputs in the forwarders? No. Why? Because they are in USA. I am sitting in India. My client server AT&T is in USA. Na? I want to collect the data from AT&T servers. That time I can't go there. Na? Okay. I can install the forwarder by using Ansible. Third party people will install it. But how you will write inputs and outputs? That's why I will use a deployment server. So we will maintain the deployment server in my location, and I will make connection to the deployment server for all of the servers, all of your client servers. Okay, with one of the terminology or methodology, we will use deployment server and we will place everything configurations in the deployment server first. Okay, deployment server first. Let's say, for example, I will place configurations like inputs and outputs here. All forwarders will come and connect to the deployment server and pull the configuration from that location and apply it in their systems. In the last class, I already explained you. One of the best example to understand the deployment server is our class. How I am teaching the class? Students are not coming here. I am not going there. Via application, they are listening the class remotely. Na? What I am teaching, everything in the application, they are listening and they are applying in their minds. Na? Same. Deployments are also there is application. Okay. Forwarders will come and connect to that deployment server and fetch that data from that application and apply it in their missions. Based on the inputs, they will collect. Based on the outputs, they will forward the data. And then the data will be sent to indexers. Indexers is a separate server. If I am getting more data, one indexer is not sufficient. No? Indexer is a server. Server having capacity of 1 TB, for example. If 1 TB is not sufficient, we try to increase 2 TBs. Okay. 2 TB is not sufficient, we will increase 3 TB. 16 GB RAM, it is not sufficient, we'll try to go to 32 GB. Got my point? That is called vertical scaling. Vertical scaling is nothing but within the server, you are increasing the hardware or decreasing the hardware. 16 GB to 32 GB RAM, 1 TB to 2 TB ROM, or 32 GB to 16 GB RAM, or 2 TB to 1 TB ROM. Reducing and increasing. Call it as vertical scaling. Sir, vertical scaling is up to the 1 point only. Na? Let's say suppose my laptop is there, sir. I can go up to 32 GB. If it is more than 32 TB, it's not. 32 GB of RAM, it won't be supported. Why? Because my hardware won't support. Some certain place, there is a limitation. Got my point? In that case, you need to go to the horizontal scaling. Horizontal scaling means one server, another server will be added. That means another server will be added. Still you are not filled, another server. Okay. But in the Splunk, what will happen is They won't keep one by one. They won't add one by one. Okay, based on we already have some definition. What is the definition is? Okay, what's your name? Mutyam. Mutyam is sending 2 TB data per day. Okay, 2 TB per day, and he is asking to store his data for next 6 months. Got my point? Definition is created. He is sending 2 TB and he is ready to send the data for next 6 months. Assume that for simplicity 100 days. 2 TB means 2048 into 100. How much GB I am getting? TB I am getting. So for simplicity 100, assume that 1 TB. 1 TB into 100. 100 TB of data I need to store. 100 TB of data I need to store for 6 months for Mutyam. Do you got my point? In that case, 100 TB I need to have storage. Got my point? Suppose here I have one server having 30 TB. That means I need 4 servers for maintaining 100 TB. Suppose one server having 50 TB. I need only 2 servers. Don't consider like that. Why? Because Splunk has one default limitation. One indexer can store up to 300 GB per day. 300 GB per day. In the case of Mutyam having 1 TB data. 1 TB means 1024 GB. That means 1 TB you are getting. That means for storing the Mutyam's data, we need at least 1024 by 300. 4 servers is needed. At least 4 servers. That means at first itself, you need to keep that 4 servers. You got my point? The first itself, you need to keep 4 servers. Why? Because as per the person client requirement, he is sending 1024 GB. One server can handle up to 300 GB. 300 GB. So the 300, 300, 600, 600, 300, 900, 900, 300, 1200. That is more than 1024. That means in the case of Mutyam, must and should you need to keep set 4 servers. Same like that. Somebody, you are getting more data. You need to increase like that. That means at a time, if you want 100 servers, 200 servers, you need to keep it. That's my point, sir. That means all 100 of servers needs to be available. That means all servers needs to be receive the data. Na? That means all forwarders are need to send the data to all indexers. Na? Yes or no? Not one server. That all will be sent to the all indexers like this. The data will be sent like this. Got my point, sir? So, for example, this is my indexer 1. Servers, one server only, indexer 1 means. No, sometimes you need to keep buffer data will be there. Na? Okay, at least we need to maintain some set of extra storage.
The requirement will increase, the client will not tell you.
Yes, yes. Sometimes unwanted data will be also received. Na? Okay, for that definitely you need storage. Na? Okay. So, for example, here 4 servers is minimum, sir. But if your capacity is not sufficient, for example, 4 servers means how much data you need to store for Mutyam? 100 TB, na? 100 TB means one server needs to store how much? No. Entirely. 100 divided by 4. That means around 25 TB of data you need to store. Is it possible to have 25 TB storage for one server in real time? No. Maximum up to 8 to 10 TB if you implement multiple disk storages also. You got my point? That time again, you need to increase it based on the capacity. First based on the daily rate. Then based on the capacity. You got my point, sir? That time maybe to store the Mutyam's data, you need to have some 10 to 20 servers. You got my point, sir? But understanding purpose, just 4 servers. Understand? Now 4 servers are receiving the data. Okay? 4 servers are receiving the data with the help of load balancer. Why? Because if server will fail, The data will be stuck there. I need to tell if server was failed, immediately I need to send the data to other indexer so that there is no missing of data to store. So that's why they will implement the load balancer. Load balancer is used for splitting the load between the multiple indexers. You got my point? If you want to split the load to multiple indexers, forwarders needs to know the active status of indexer. Yes or no? If they don't know active status of indexer, how that forwarder will send the data to indexer available indexers? So for that, you need to write a one parameter in the forwarder, that is use ACK equals to true. Acknowledgement. Forwarders are keep on checking the acknowledgement. If indexers send the acknowledgement to forwarder for active status, then it will send. If you don't get acknowledgement, it won't send. It will send to the available indexer only. Like that, you let you no missing of data, and you can store huge amount of data into a Splunk index without missing any single data. Okay. Now assume that 1 hour, the first 1 hour data will be sent to indexer 1. Assume that. Next 1 hour data will be into indexer 2. Next 1 hour data into indexer 3. Next 1 hour data into indexer 4. Now I want to search the data. So for that, I need to keep a separate server again for searching purpose. Do you get my point? And everything, all indexes needs to be connected to that server. Okay. Your Google search is connected to your Google servers, na? Same like that. If this is organization data and this is our search bar. Okay, that is called search head. What is called search head? Here you will write a SPL query. What is the query? SPL query, search processing language. It is like a query only, like a SQL only. For example, we have a query, search for the storage. Okay, filter the type of data, and a table, rename, replace, search, chart, time chart commands. Okay, stats command. Different commands are there. If you know 30 to 40 commands, you will be master in the SPL. No worries. You can create like a Tableau Power BI. You can create reports like visualizations, like pie charts, bar charts, dashboards, whatever you want, you can go. In the Tableau kind of activity, you have a calculations. At the time, they will use a calculation functions. Okay, and somewhere some people are using for LODs in the Tableau kind of activity. Don't deviate it. So some critical tasks are there. Here, simple eval command. Evolve, automatically it will evolve whatever the calculations you want, mathematical calculations, if condition, case functions, everything it can be applied. Time conversions, date conversions, everything it can be done. Simple SPL query. Okay, if you write a query, for example, for last 4 hours I am storing the data. I am writing a query for last 4 hours. That means data will be searched from all indexes. No? Yes, sir. Why? Because my search is for last 4 hours. Data also received for last 4 hours. That means all indexes needs to be searchable. Yes or no? That is the means all indexes available only, you will get 100% data. Suppose if indexer 1 fails, indexer 1 got failed. Indexer 1 got failed. In that case, you are searching for the all time. Last 4 hours I am searching. Is it possible to search 100% data? No. Why? The first 1 hour will be received to indexer 1. It is not available in other indexer. You got my point? So in that case, the data is individual. Whatever the data in the indexer 1 is indexer 1 only. Whatever the data in the indexer 2 is indexer 2 only. Likewise versa. If indexer 1 fails means no data is available from that indexer. You got my point? Yes or no? Let's say, assume that I want to get the data also. Even though it is failed also, I want to get it. Then you need to keep a backup server. Backup server. Yes or no? Backup server. If you keep a backup server for one indexer, what about indexer 2? What about indexer 3? What about indexer 5? What about indexer 30? For all indexer 30 indexers are available. For all, you can keep the backup. Is it possible? It's not possible. That's why it is not a correct approach. Backup is not a correct approach. So for that, they will use a clustering. What is that? Clustering. Indexer clustering. We call it as a indexer clustering. IDX cluster. So what is the use of clustering? Cluster is helpful for maintaining the high availability of data. What is the use of clustering? To maintain the high availability of data. IDX cluster. So to maintain the high availability. How it will maintain the data? So this data will be maintained as some other indexer. Copy, creating a copy, sir. Let's say, for example, sir, you have a BTech certifications and your degree certifications are there. So how many copies you have for that? Only one copy. For me, I am maintaining 3 copies. I am maintaining 1 copy on my Gmail, 1 copy on my phone, laptop, and 1 copy on my drive, hard disk. Why I am keeping 3 copies? For example, if my laptop was corrupted, I have a copy on drive. If my drive was corrupted, still I have a copy on Google Drive. Still you are not feeling happy to have these copies. You can increase more copies. You can have 1 more copy on some OneDrive or Dropbox, something. It's all depends. You got my point. But if you want to get a high availability, you need a copy, replica. You got my point. Replica. So that's why this data will be maintained as some other place as a 1 copy. Okay, this data will be maintained as some other place as a 1 more copy. Like that, based on our requirement, we can maintain the copies of data. Huh? It's none of our business. Splunk will take care of it. We need to tell how many copies we need to maintain. That only. Hardware, that based on that we need to choose it. Previously, we talk about 7 servers is enough. But copies maintaining means 7 into 2. 14 is required. 30 is required. When you are expecting high availability, definitely cost will be increased. You got my point, sir? Huh? Definitely. So that definitely you need to maintain the copies of data. But how it is maintaining, it is none of our business. We need to just tell that how many copies we need to maintain. Who will tell that one? CM will tell that one. Who is that? CM. Cluster master is telling that. Sir, everything will be happened with the peer nodes only. This is peer nodes. What is that? Pair nodes. Everything will be done with the peer nodes only. See, what I am teaching, everything you are only listening and you are only applying the exam and attending the interview. See, cluster master is initiated and peer nodes will participate. You got my point? What it will initiate? I already told you, we need to initiate how many identity copies of data needs to be maintained. Okay, that will be initiated with the 2 factors. One is replication factor. Replication factor. That is called RF. Actually, default value is 3, sir. It can be customized, sir, but I am telling default value. Such factor. Such factor. SF equals to 2. Default. Understand, sir? Replication factor and such factor. So what is this mean by replication factor and such factor? I am initiating CM to tell replication factor and such factor. Okay, replication factor is 3, such factor is 2. What it mean? Based on these 2 factors only, indexer P nodes will maintain the copies. So that means before knowing this replication factor and such factor, I would like to explain one more concept. All you know that data is received by indexers or not. Forwarders are sending. Data is received by indexer. That means data is receiving. Okay. After receiving the data, what you are doing? If you want to do some customizations, if you want to do some parsing activities, parsing means line breaking segmentation. Like any actual events are not breaking, you can break it. Okay. So customization, transformation, and the filtering. Call it as a parsing. So after receiving, you can parse your data. Okay. After parsing, what you will do? You store it. Storages. So that means indexing. Storing means indexing. That my point, sir. Indexer will receive the data, parse the data, and store the data. And storage will be such by such it. Okay. While Splunk is storing the data, Splunk stores two types of data. How many types of data, sir? Two types of data. Two types of data. One is raw data, and other one is metadata. What is that? Metadata or TS-IDX data or index data. Anything is fine, sir. Metadata or TS-IDX data or meta or index data. That means Splunk is storing two types of data. One is raw data and other one is a metadata. Understand, sir? Now, what is raw data and what is metadata? Anybody?
Whatever we are receiving from the forwarders, that is, I think, raw data. Metadata, maybe it's like data about a data, but I don't know here.
Yes, same data about a data. That is data pointing to your actual data. Data and metadata. Data engineering లో చెప్పలా ఇది తెలియకుండా డేటా ఇంజనీరింగ్ ఉండదు. Without knowing this, there is no data engineering. You are working as a data people, must and should you need to know about this. Any type of data will be a raw data. Whether it is structured, unstructured, semi-structured, parsing data, customized data, whatever it may be, uncustomized data, whatever it may be, actual data is called as a raw data. Actual data is called as a raw data. Metadata means the data which will pointing to your actual data. Normally, Google statement is data about a data, and my statement is data which will pointing to your actual data. For understanding these 2 points, I will explain you one example. Do you know book? This is the book. You have 300 pages of book. This 300 pages, 298 pages is a raw data. 298 pages is a raw data. The first 2 pages are metadata. First 2 pages are metadata. So content pages are 1 to 10. Splunk introduction, 10 to 20 components of Splunk, 30 to 40 installation, 40 to 50 some other. So immediately with the help of content, you are pointing to your actual raw data. Na? Yes, sir. Okay. Then what is information? Information. Whatever the data it should be, the data needs to be understandable and useful for taking decisions. Collection of data only. Information is nothing but collection of data only. But the data needs to be take decisions. Sales is the raw data. Average sales is the information. Understand? Yes, sir. So very important know this. Information, forget about raw data and metadata. So let's say, for example, raw data. This is I am the person. I'm the person, whatever it may be, whether it is black or white, whatever it may be, t-shirt or white, whatever it may be. Actual person is a raw data. what is metadata? The image, which format it should be. The image, Ravi image is there. The image, which format, JPG or anything, what is the file size, at what time it was created, by whom it was created, which location. Okay, these all will be metadata. There is a table, entire table will be raw data, including column names. What is the minimum value? What is the maximum value? What is the total number of records? What is the total number of columns? What is the at what time it was created? By whom it was created? This all will be a metadata. Understand? So now Splunk is receiving the raw data, and it will parse it, and it will store the raw data in the form of compressed. Splunk will store your data into a compressed and encrypted. The raw data will be compressed and encrypted in the Splunk indexing.
Compressed data can be searched.
Yes. How it will be searchable? With the help of metadata. So when it was storing raw data, Splunk was storing raw data, Splunk automatically creating metadata for that particular raw data. Splunk only creating, sir. I am not creating. While you are storing raw data, for this raw data, Splunk is creating metadata and storing along with the raw data. You got my point? So that raw data is in the form of journal. The file format is journal.gz, zip format. Zip. Metadata is in the form of TS-IDX files. TS-IDX files. So it is too early to know that, but I will show you that point. If it is a Splunk, this one, program files, Splunk, where lib. If it is a storage, this is my index. Assume that tutorial index is my index. Okay, in that this is the DB storage. So in that my DB is raw data is in the journal where zip file format, and then TS-IDX will be this one. Understand, sir? So the raw data will be automatically created with metadata, and it will both will be stored. So raw data is in the form of journal, whereas metadata is in the form of TS-IDX. Who is creating TS-IDX files? Splunk. Yes, Splunk. Metadata is created by Splunk. Is it possible to create by you? Yes. Is it possible? You can create it also. How to create it? Everything I will show you later. You can also create your own metadata. No problem. Okay. Now, how many types of data are there, sir? Two types. One is raw data and metadata. If you metadata is searchable, if you try to search your data, it will search for the metadata, and metadata will point into your raw data. The search will be on TS-IDX files. You got my point? And from data is searching from raw data. And who is searching? TS-IDX files. That means that if you are maintaining a copies, you need to maintain both the data as a copy, na? Yes or no? Definitely you need to maintain both copies. Got my point? That means raw copies you need to create, meta copies you need to create. So that is the replication is a raw copy. Replication is a raw data copy. Whereas search factor is a metadata copy. TS-IDX files. TS-IDX data. Understand, sir? TS means time series index data. Time series index data. Understand or not? Online people. Understand or not?
Yes, sir.
Now, here I am mentioning replication factor equals to 3, search factor equals to 2 as a default. Why I mentioned, or Splunk is recommending default value of 3 and 2. Okay, that means 3 identity copies of raw data and 2 searchable copies of raw data. Searchable copies of metadata. There is a condition called replication factor always be greater than or equals to search factor. Replication factor always be greater than or equals to search factor. This is the condition, sir. This is the condition. Based on that only, he recommend you. Splunk is recommend you. Replication factor is 3. Search factor is 2. What is replication factor greater than or equals to search factor? I will try to explain it. There is a book. 3 books are there. 3 contents are there. Is anything happen? Aram, you can read your books, no? 3 books, 3 contents. Every book has its own content. Aram, they can read. You can read it. 2 books. Sorry, 3 books. Only 2 contents. One book don't have any content. Is any problem will come? Three books. Only 2 books having a content. Third book don't have any content. Is any problem? No problem.
Why we are getting the data from one book? We don't need to access, right?
Why? Because at the time of my childhood, if I want to buy a police, I will tear my content page only. Is any necessary to have a content page? No problem. Tomorrow I will create again. I have raw copy now. Tomorrow I will create it, sir. I have a raw copy now. You have a book. You don't have a content, you can create yourself. You got my point? 3 copies, 3 raw copies, through meta copies. Very good. Aram se you can do. 3 raw copies, 2 meta copies only. No problem. For the third raw copy, you can create your own content. You got my point? Now tell me, 2 raw copies, 3 meta copies. Where you get the third copy, sir, without a raw copy? Meta copy is a highest, sir. Raw copies are 2 only. Without a raw copy, how you are getting third meta copy? Raw copy only na metadata created. Without a raw data, how you create a third meta copy? That's why he is recommending you replication factor always be greater than or equals to such factor. You can make 3 equals, no problem. Equal is no problem. But not more than such factor. Why? Because without a raw copy, how you will get a meta copy? If meta copy is not available, okay, very good. 3 raw copies, 2 meta copies, very good, no problem. We will create 1 more copy by our own side. You got my point? Yes, sir. Sir, okay, your condition is very good. Then why this guy is keeping 3-2? 3-3 is okay, na?
Yeah.
You understand my condition, sir? Okay, better to go with 3-3, na? Why this guy is recommending you 3-2? Why? Because in the Splunk there is a strategy they are using. So with that strategy, they are recommending you 3-2. He is not telling that you just go with strictly go with 3-2. If you want, you can customize it. But he is recommending you 3-2. Why? Because, see, observe. Very important class. Very, very important. Observe. For understanding purpose only, I am telling, sir. So they assume that this is your raw copy. This is your raw copy. And this is one other raw copy. This is another copy. This is your another copy, individual data. Assume that this I am talking. I need to maintain 3 copies. One is original copy and other one is duplicate copy. Here I maintain 1 copy and here I maintain 1 more copy. Assume that. So for this copy I am talking, sir. This is our original copy. For this 2 duplicate copies I create. Raw copies. 3 na? One is original and other one is 2. Understanding purpose. For this one metadata copy will be there, na? For this, one more metadata copy will be there. No? 2 meta copies. Is actual meta and other one is extra copy. Now, if you write a such query, such will be work on metadata. So metadata will be pointed. Okay, metadata will be pointed, and then from to raw data it will search your data. Assume that this data is 1, 2 numbers. 1, 2 numbers is searchable with the help of meta copy. Now suppose this got failed. Now one raw copy failed and one meta copy failed. Still you will search your data or not? Yes, we have another raw copy and another metadata copy. Na? You can search your data. Still you can search your data. Okay, still you can search your data. Yes or no? Suppose, for suppose, this got failed. Is it possible to search your data? చెప్పు లేదు కదా మెటా కాపీ లేదు కదా there is no meta copy no? Maybe it is not searchable. Yes sir, maybe, but it will be searchable. How it will be searchable means I already told you, one strategy you will use. The strategy is that Splunk automatically create a one more copy for the existing raw copy. You already have a raw copy na? From that it will create one more searchable copy. Once you have a one failure, cluster needs to be maintained 2 copies na? Immediately the extra copy will be created. So once this was failed only, first indexer failed only, immediately one more copy was created. Why? Because cluster needs to be maintained 2 copies na? Immediately it will maintain one more copy, so that one copy will fail also, still you will search your data. Got my point?
Yes.
But third indexer fails means, as logic itself it won't work. Why? Because your replication factor 3 means 2 identity copies only. So 2 peer node tolerance only. Peer node tolerance. That means up to 2 indexers will fail also, you will get 100% of data.
Give an example with the indexer. We are talking about the complete metadata, yes?
Complete
metadata. I mean complete raw data.
Complete raw data point of view.
You are giving example with only index.
Why? Because it will maintain the copies of meta only, not raw. Raw is actual data.
Example with this indexer only, yeah? That indexer will fail. Yes. This example should be given when this complete the red box. One copy of that red box.
We can give it, but understanding purpose I am taking 3 indexes. Okay, where the copies will be there, we don't know actually. Splunk will take care of it.
It is copy of that complete.
Wherever, for example, I said here the copy is there. Maybe here not there. It is in the indexer file.
No, I understand. You want to say that raw data, that means complete the red box copy.
Yes. It will be maintained in the red box, entire red boxes. Entire red boxes consists of multiple indexers. Every indexer has his own raw data and own metadata. Then the entire cluster, it will maintain 3 identity copies of raw data and 2 searchable copies of raw data. But for understanding purpose, I am telling here raw data, like that I am telling. Okay, here maybe it is not available in indexer 2. It will be in the another indexer. It's none of our business. Splunk will take care of it. For understanding purpose only I am teaching. So now this is raw data and this is your metadata. If this will fails, why? Because your replication factor is 3 means 2 indexers will fail also, you will get. Third indexer fail, you don't get 100% data. That is the logic actually. If you want more indexers fail, you need to increase the replication factor. If you keep replication factor 10, 9 indexers will fail also, you will get 100% data. You got my point? If you keep replication factor is 100, 99 indexers fail also, you will get 100% data. But here 3 copies means Until 2 indexers will fail, you will get 100%. Understand, sir? Yes, sir. So like that, it will create one more copy, na? That copy will be extra. Okay. Now, for example, these two are coming to the picture. It was active. Now, how many raw copies are there? These are active, sir. Failure indexes are active. How many raw copies are there? Two. Two or three? Three. One, two, three. And how many searchable copies are there? Three. Why? Because one extra was created, na? Now third copy is extra only, na? What is the use of having extra copy? It is storage button only, na? If you want to remove, you can remove it manually. Manually only possible. Automatically it will create. Manually, as admin, we need to remove it. That can be done with a master. That can be done with a master. Understand, sir? Yes, sir. In that case, for example, if you keep 3, how many extra copies will be extra? 3 copies will be extra. Now in the case, only 1 copy. If you keep 3 means more extra copies will be growing. That time you need to maintain huge amount of storages. Okay, that's why they are recommending you 3 and 2. You got my point, sir? So based on that, replication factor means how many identity copies of raw data needs to be maintained on the cluster, entire cluster. Search factor means how many searchable copies of raw data, searchable copies of TS-IDX files needs to be maintained on the entire cluster. Got my point? Based on the replication factor 3, you will get 2 peer node tolerance. 2 peer node tolerance. Understand, sir? If you want to increase the more peer node tolerance, you need to increase the replication factor. Like that, you can maintain high availability of data, even though any indexer will fail also. Understand, sir? Any question? Any question? Now, my question is, indexer 1 fails. Did you get 100% data?
Yes.
Yes. Indexer 2 fails. Did you get 100% data?
Yes.
Yes. No. Very good. Indexer 3 fails? No. Why? Because replication factor is 3 only. Clear? Now my question starts again. Sir, all indexers are available. Very good. CM fails, what will happen? This is very, very important question. CM fails, what will happen? Is data is searchable? Data still searchable, sir? Very important information. Data still store. Data will store without interruption. Third one. Replication. CM only initiating the replication. CM fails means replication will be happen. Still replication will be happen. How it will be, I will tell you. Understand, sir? Still replication will be happen. Then what is the problem with CM fails? Without CM, you can't add one more indexer into the cluster. Without CM, we can't add one more indexer into cluster. Understand, sir? The second or fifth point. Without CM, we can't remove excess copies. We can't remove excess copies which was created while failure, indexer failures. I already told you now, excess copies was created, which was created automatically, and you need to remove manually. Na? That can't be done. Why? Because CM only doing. You can't involved in the bucket fixing activity. Bucket means actually storage, sir. Fixing activities. For example, suppose while storing your data, one data will be stored extra, or sometimes a bucket will be corrupted. It won't be stored. You need to involved in the fixing activity, resyncing activities that can be done with the CM. Just initiation, one parameter will be there in the UL level. If you click on it, bucket fixing activity will start. If you click on delete, excess copies will be removed. It can be done in CM only. Next, last very important point. Without CM, we can't manage new configurations to the indexer peer nodes in the cluster. Sir, if you want to receive the data, forwarder is sending the data, indexer needs to be receive the data, na? Indexer needs to be receive the data. After that, it needs to be store it. Receiving input, storing indexes. That is a configuration only, na? Who will do that one? If you have 100 indexes in the cluster, all 100 indexes individually you will do. No, CM will do. So previously forwarders will be managed with deployment server, na? Now in the clustering, configurations will be managed with a CM. If you want to manage the configurations in the indexers, CM. Without CM, how you will manage it? Already existing configurations will be work. But your new configurations you want to deploy, it's won't work. Understand, sir? So that means these are the impact of CM. Now first tell me, data still searchable. See, there is no connection to the CM for the forwarders. One indexer available also, forwarders will send the data based on the load balancer. There is no connection to CM. If CM fails, means what will happen? Forwarders still send the data. Yes or no? Next. But such and CM having a connection. What happened if you are having a clustering? If you are in the clustering, okay, what will happen is CM will connect to the indexer clusterings. Suched is connecting to the indexer clusterings via CM first. Suppose there is a Mutyam. His brother came to meet Mutyam. He directly talk with Mutyam. Is it possible? How? Without my permission, how he will talk? He is in my class now. He's outside, he can talk. He's in my class. First, Mutyam's brother needs to take permission from me. Then I will grant a permission. Then he will talk directly. You got my point? Yes, sir. Now, again, my question start here. I grant a permission to Mutyam's brother. He talk with him. After completion of his talk, while going again, he will come back and he will talk again to Mutyam. Is it possible? Yes, no problem. Why? Because he already take a permission from me now. First authentication was done now. So that second time he don't need. Why? Because he has an identity. Mutyam, where he has everything, he has information. So that second time he will come and directly talk with Mutyam. Same like that, Sachet also. First he will take the permission of CM. Okay, I am the Sachet. Okay, I am going to connect to your available indexes. Please give the permission. He big, and so that CM will give the granting. So CM granted, immediately Sachet will go and connect it to all of available indexes. Why? Because all available indexes information will be on CM. You got my point? Now Sachet will go and search the data from the indexes without the next authentication. First time only authentication. You got my point? This is for the authentication purpose, sir. Now you already authenticated, na? That's why even though CM fails also, still data is searchable. I already told you. Data will store without interruption. Data still searchable. Why? Because you already get a authentication previously. Okay, understand, sir? Please remember, such will go and connect to CM only, but first step. Once you get the authentication, no need to contact every time. It directly deal with the indexers. How it will be deal with the indexers? Actually, every indexer have his own GUID. GUID. With that GUID, they can identify it. Okay, what will happen? First authentication, I will share the GUID. CM will share the GUID of all indexers to the subject. GUID of all indexers to the subject. So that subject will automatically search the indexers data by using a GUID. Identity, sir. Identity. One ID. Okay. So what will happen? First you will take the authentication of subject. Subject take the authentication from CM. CM automatically share all GUIDs of available indexers to the subject. With the help of GUID, they will go and search the data so that there is no interruption of searching without CM also. Understand, sir? Next point will be still replication will be happen. How? CM only initiating, but it was initiated. So that same GUID will be helpful to replicate the data each other. With the help of GUID, they replicate the data each other without CM also. Why? Because GUID is already shared. What happens? CM will do. CM will share the GUID to subject as well as other availability indexers also. Other indexers also. For example, you 4 are indexers. Mutyam ID will be shared to this girl. This girl index ID to others. Like that, all you 4 IDs will be shared to each other. I am only telling you all guys are for Splunk. So that immediately you share your IDs. Along with that, you will share your ID to subject also. Who will do that? CM will do. That already done, na? So that with the same ID, subject will go and search the data and data is replicating each other. Data is replicating each other. So that there is no interruption on searching, there is no interruption on storing, there is no interruption on replication. Then without CM, what will happen? We can't add a one more indexer into the cluster. If you add it also, how? CM is not available, na? Who will share the ID? For example, sir, I am not available. I just outside. Somebody will sit into the class. You don't know why he came. Until I will tell he is also some Splunk guy. You are simply saying that why he is sitting in the middle of the class. You don't ask him. You just worry about it. Why this guy is sitting here? You got my point. Same. Once I am available. If any person will come also, I will tell you. Arey, this guy is a new person. Okay, like you. Please take his ID also with you. Immediately I will share the same ID to newly added ID to other members, other peer nodes, apart from such ID also. So that it is easy. But without CM, it's not correct. That only I am telling. Without CM, we can't add a one more indexer into the cluster. Without CM, we can't remove excess copies. I already told you, excess buckets will be created. That will be done with a CM. There is a simple excess copy removed option. You just click on it. Even bucket fixing activity also same. And also, CM already initiated some configuration so that it is receiving and it is storing. But assume that I want to create one more new storage. Without CM, how can do? CM only responsible for configuring, na? So CM is not there, so that you can't deploy new configurations. You got my point? These are the possibilities. Any question up to now? Online people, Sai Prasad. Now I will close you within 5 minutes with 2 conditions. CM fails on 12 p.m. CM fails on 12 p.m. Okay. CM fails on 12 p.m. In that case, below points all will be repeated. Okay. Now, CM fails are still IDX1 got failed at 12:30. Got my point, sir? 12 p.m. CM fails. After 30 minutes, IDX1 got failed. Now, what will happen?
Till we can search the data.
Still you can search your data 100%. 100% data. Why? Because already replication is happening. Then what happened? Still you can search your data. Very good. Whatever the CM fails, that all points will be same. Okay. But here replication error will come. Repeat error will become. Replication error will come. Why? Because one of the identity was missed in the entire cluster. Na? I am telling the while I am down, master. I am telling you 4 people. You have his own IDs. Please share it. Okay. Now I am failed. You also got go out. What's your name? Nitin also failed. Immediately you guys think that Mutyam and this girl and this boy think that, sir, tell that 4 people na, only 3 people only. So something happened, so that it stopped replication. It stopped replication. You got my point? With misunderstanding. You got my point? Why? Because I said 4 people, you need to replicate each other. But one of the guy failed. And I am not available. Okay, no problem. You continue 3 people. I am not available to say that. That's why they will, within the confusion, they stop the replication. Got my point, sir? Yes or no? Any question? No.
Replication at what frequency it will be? Replication.
It's keep on replicating, sir. Frequency, it's keep on replicating. If today is not available, also tomorrow it will replicate. Okay.
If replication was done before the failure of CM,
It will searchable.
it will search, yeah?
If I already have a copy, very good. Now replication error came. Now please tell me at 1 p.m. IDX2 failed. IDX2 failed on 1 p.m. sir. Please tell me in that case. CM failed. 12:30 IDX1 failed. Now still IDX1 also failed. But indexer 2 got failed on 1 p.m. Replication error is there, continuously happened. Then what happened in that case, in the scenario? Please observe, sir. May or may not search 100% data. May or may not search 100% data.
But if it will give error, then
It won't throw error.
it won't show error.
May or may not, it will search the 100%. In first case, 100% data will be searchable.
But in second case, there will be no error.
No error. It will give you incomplete data. 100% data searchable. Here in the first case.
Oh, here also.
In the second case only, not 100% data. Why? Because that also may or may not serve. Why? Because, for example, please observe, sir, very carefully observe. 12:30 indexer 1 failed, na? Replication error came, na? From 12:30 onwards, data is receiving, na? Assume that the data is received to indexer 2 from 12:30 onwards. 12:30 onwards, assume that the data is received to indexer 2. Now it is 1 p.m. Whatever the 30 minutes of data is in indexer 2. That is not replicated, na? Now index 2 fails means that 30 minutes data is not searchable, na? Yes or no? Yes or no? That only may. May means may not. You can't search the data. If the data is in the part of failure indexer on the time of replication error. Suppose whatever the 30 minutes is received to indexer 4. Now failure indexer is 2. That means you can search it. Previously already replicated. Whatever the 30 minutes data which was not replicated is in the other indexer which is already available. You can search it. That's why may or may not. Got my point, sir? So please remember these points. So this is about indexer clustering.
But you tell me, first case it gave replication error. We said before,
First case not. CM fails means still replication will be there. When the CM fails, indexer 1 fails. Then only replication error will come. 100% data searchable. 100% data searchable. Why? Already previous data is replicated. Na? Now on that time onwards, replication is not happening. The whatever the data coming on that period, okay, that data is not replicated. If you search that data only, if it is a failure indexer, you can't search it. If it is not a failure indexer, you can search it.
But in first case, it will give error. Replication error.
Where error? It won't throw any error. It will say that it satisfied the not a replicated. It's just showing that replication factor is not met. Replication factor is not met.
I thought it will throw the error.
No.
It will not allow you to search.
How much time it will take index one to
Within fraction of times. Within a fraction of times. It is that. If it is something real-time data means within fraction of time. If it is something like upload data, like batch data means sometimes some lagging will be there. If you have more lagging also, no problem. It is a batch data only. Na? But real-time data complete within fraction of time it will. This is about indexer clustering. So that with the help of indexer clustering, so we are maintaining high availability of data, even though one indexer will fails also, we are getting 100% of data from the searchable. So tomorrow class will be searched clustering. So very important class on tomorrow. I think tomorrow we'll completed the components of Splunk. Last 3 hours and this 2 hours. Total 5 hours of classes is heart of the Splunk. If you know these theoretical classes, that is more than enough to clear the interview of 30%. 30% interview will be cleared here. So same thing we are going to implement 70% as a practical. Understand, sir? That's all enough today. We'll meet on tomorrow with a more content. Thank you. Thanks for your time. Have a nice day.